My name is Anthony Sarandino, and I'm a grade 11 student at Bishop Ryan Catholic Secondary School. And the purpose of my project was to design and prototype a crack detection system that uses a robot to climb a concrete wall in a neural network to accurately detect cracks in the concrete. I've always had an interest in inspection robots, and when I was doing research this year for my project, I realized there was no inspection robots on crack detection for bridges and other concrete structures. I also wanted to choose a project that would allow me to use a neural network in deep learning, because that's another one of my interests. At the start of my project, I laid out several engineering goals, but these are some of the main ones. Number one, I wanted to create a fully functional robot that could climb a concrete structure. Number two, I wanted that robot to be able to take a picture every 12 inches until the entire concrete structure was covered. And number three, I wanted to create a neural network that could learn and study the images that the robot took so that it could accurately detect the cracks in the concrete. My project is broken down into two different sections. The first being the neural network. After countless hours of research, I determined that I need to use a CNN, a convolutional neural network. A convolutional neural network is a neural network that is commonly used for image classification. Image classification is exactly what I needed to properly detect the cracks in the concrete. After watching and following multiple tutorials, I was able to code the training module for my neural network. The next step was to find the photos to train the neural network with. I went online and I found 20,000 images of concrete with cracks and 20,000 images of concrete without cracks. After training my neural network and some testing, I discovered that my neural network was 99% accurate when detecting cracks in the concrete images. The second section of completing my project was building the robot. The first thing I had to do was complete a series of calculations that helped me to determine how much torque the motors needed and how much suction the robot needed to stick onto the wall. I had to take into consideration that the surface I was climbing was concrete. This meant the suction needed a certain foam seal to stick onto the porous surface. As you can see here, this is the test area I used to test my robot. To the far left is my pneumatic system. The pneumatic system consists of vacuum pumps and solenoid valves turned on and off to control the suction flow to the robot. The pneumatic system is connected to a 4-channel 5-volt relay that is also connected to the main controller. The main controller controls all 4 motors. In the video you see here, my robot is climbing. The algorithm it uses to climb is similar to how a human would do a pull-up. The video is also sped up due to how long it takes for the robot to actually climb in real time. According to my calculations, the robot can climb 10 feet in an hour. The next part of my project was the image capturing system. The image capturing system needs to take a picture every 12 inches the robot climbs. In order to know when the robot climbs 12 inches, I use the LiDAR. The LiDAR points to the ground and takes the value, and every time 12 inches passes, a picture is taken using this camera. All these photos are stored in an SD card, and the entire system is powered by an Arduino. Another one of the problems I ran into was the position and placement of the suction cups. After countless tests and different prototypes, I found that the best position was 2 suction cups on each hand and 2 in the body. Another problem I encountered was getting 4 stepper motors to work at the same time. In order to do this, I used a 3D printer board. This meant that I had to configure the firmware so that the motor could hold all 4 motors. Since I was new to the 3D printer board, I had to learn how to tweak the software. Another problem I encountered was overall testing the robot. Ideally, I'd like to test the robot outside, but due to it being winter, I had to build my own testing ring inside, which meant that the wall could not be as tall as I wanted it to be. There were 2 big surprises that came with my project. The first one being how powerful the suction cups really were. When testing the suction cups for how heavy the robot would be able to hold, it carried double the amount I expected. The second surprise I had with my project was how well the neural network actually worked. I consistently tested it and tried tricking it with different pictures, and every single time it would accurately detect if there was a crack. I was very impressed with the accuracy of it. I'm very happy with my latest prototype, although there are some things I'd like to change. Other than the fact that I'd like to create the body out of aluminum, I'd also like to add sensors to each limb that track where the limbs are while it's climbing so it auto-adjusts. Finally, I'd like to get better stepper motors which have more torque but don't add any weight to the robot. After 8 prototypes and multiple iterations, my robot was able to meet all my engineering goals. It was able to climb a concrete wall, take a picture every 12 inches, and have a neural network that was accurately able to detect cracks in the concrete. Overall, I had lots of fun creating this project, and I spent over 1,000 hours studying and learning how my robot was going to work. I'm very excited to continue working on this in the future. I'd like to acknowledge many people. Firstly, I'd like to acknowledge my brother, who helped and inspired me throughout the process of completing my project. Secondly, I'd like to acknowledge my parents, who's always supported me. Finally, I'd like to thank the people who's answered any of my questions I've had. This includes suppliers, friends, relatives, and teachers.